Hello. So today we'll be going over experiment 3, which is the tryptophan and tyrosine determination. We'll do questions 1 through 8. So the first question asks us to calculate the amount of solid guanine HCl needed to prepare 10 milliliters of the 6.2 molar solution. So first we'll convert 10 milliliters to liters. So 10 milliliters will equal 1.01 liters. Then we'll multiply by the 6.2 moles per liter, which comes from the 6.2 molar solution. Then we'll multiply by the molecular weight, so 95.53 grams per mole. And this gives us 5.92 grams. And so that will be the amount of solid guanine HCl needed. So the weight of this was made by the TA, so we didn't get a weight. So part 3 asks us to calculate the concentration of guanine HCl in the cell in part 2 after the addition of the zymogen. So for this, we'll use the formula M1V1 equals M2V2. So our N1 will come from our 6.2 molar solution. So 6.2 moles per liter. Then our volume 2 we can set equal to 3 milliliters because that's the volume of the cell. And so we'll convert milliliters to liters. So 1 liter is 1,000 milliliters. And we'll set this equal to, so M2 is what we're solving for, the concentration. And then our V2 will be 3.1 milliliters because we're saying in our cell we have 3 milliliters and we're adding an additional 0.1 milliliters. So that's how we get 3.1. And again, we convert to liters. So 1 liter is 1,000 milliliters. This gives us an M2 equal to 6 moles per liter. So 6 moles per liter will be the concentration of guanine HCl in the cell in part 2 after the addition of the zymogen. So for question 4, it says net absorbance of chymotrypsinogen A at 280 nanometers from part 1. And so from our experiment, this was equal to 0.801. Question 5, so we're going to determine the chymotrypsinogen A concentration. And it wants us to determine it in milligrams per milliliter. And we determine this from the absorbance in item 4 and the optimal factor. So for this, we're going to use the equation. We're going to use the equation absorbance at 280 is equal to 2 times the concentration. 2 times the concentration. And so the absorbance is our 0.801, and we set this equal to 2 times concentration. This gives us a concentration of equal to 4.4005 milligrams per milliliter. And then to find the molarity, we take our 0.4005 milligrams per milliliter and we multiply it by, we convert grams or milligrams to grams. So 1 gram is 1,000 milligrams. Convert milliliters to liters. So 1,000 milliliters in 1 liter. And then we multiply by weight. So moles there's 250 grams per mole. And so the molarity is going to equal 1.602 times 10 to the negative fifth moles per liter. For question 6, it asks us to find the number of cysteines in the chymotrypsinogen A. And so from our literature, we know there are 5 cysteines. So number 7 asks the total concentration of cysteine in chymotrypsin A So number 7 is the total concentration of cysteine in chymotrypsin A. So we're finding the moles per liter, so the molarity. So we use our 1.602 times 10 to the negative fifth moles per liter from question 5, part B. And we multiply it by the number of cysteines. So there's 5. So we multiply by 5, and that gives us 8.01 times 10 to the negative fifth moles per liter. So finally, number 8 asks us to state the Beer-Lambert formula. So it's going to be A equals epsilon times CB. And so that's it. Thank you.